next speaker is Richard Caldo of Proven Energy, and the agenda said it was going to be about the Bahamas, but Richard's going to surprise us with another piece here. And Richard joined Proven Energy in 1989. He started working with Gordon Proven on electrical and electronic control systems back then. The company became more involved in renewable sector, and Richard began to specialize in wind turbines. He's a systems manager and oversees production, installation, and system design. He's the longest serving member of the Proven Energy team and has been very instrumental in the company's growth. So we need to figure out how to get off that one.
Yeah, I don't think the PowerPoint's there. Is this Kate's laptop?
Okay.
Is this Kate's laptop? Because I don't see the PowerPoint there.
Here we go. I might just add, Proven turbines are starting to be installed in Alaska, and I think there's one in the Bristol Bay area, and maybe some others. So look forward to your presentation.
Thanks. First of all, thanks for letting me speak today, and I've been told, regards to the accent, I will talk very slowly so that you can understand. I was really surprised today. I've had 4 people come up to me today and actually said that they have installed Proven turbines in Alaska. We have just now 30 units within Alaska, and Proven Energy, we're a well-known brand throughout the globe, but I thought that we needed a presence in Alaska, and that's why we came here to this conference. I've got to say it's been a learning curve for myself for the wind diesel. Normally within our sector in small wind, we see the diesel set as the add-on to the turbine for the power range that we do. So we are a global leader in the small wind between 1.5 and 50 kilowatts. We manufacture the turbines. We have been for 20 years in Scotland. We have a facility just south of Glasgow, and then we have our corporate offices in East Kilbride, which is a suburb of Glasgow. And during the next few months, we'll be opening a facility in Elgin, in Illinois, and we hope to develop that. We'll have training and services there. We'll hold stock and eventually be assembling in North America as well. Within our fleet, we've got excess of 60 million run hours annually, and we contribute, it says there, over 10%. It's 14% of the small wind production. We're shipping in excess of 1 megawatt of turbine per month now, so really rapid growth from when you'll see our history. 1980, Gordon Proven founded the Proven, and he left the nuclear industry. Gordon was Babcock Engineers' senior technician. For his sins, he worked in Libya. He did the nuclear power stations for Colonel Gaddafi. He came back, he commissioned Sellafield, commissioned Dounreay, and said enough's enough, this is not what I believe in, and walked away financially as well. He was very well paid, and started up a small engineering firm, bespoke engineering. The passion was renewables for the company, but in those days we were laughed at as a company. I remember going to a similar conference to this for the Scottish Development, early 90s, and we said we're going to build turbines, and we were laughed out of the room. We're the only surviving manufacturing company from that. All the other manufacturing companies, engineering companies, have now closed in Scotland that were there at that time. So we were seen as mad hippies, tree huggers, as they used to say. But we've developed, and now the industry has changed, and that's part of this presentation. I just wanted to give you a little bit of background about Proven before we move forward. So You can see there our 100th installation in 1998, and to date now, as of today, I think the figures just changed. It's now 4,000 installations that we have worldwide. Well, 4 main turbines. We do the Proven 7, 11, the 35-2 and the 35. That's the turbine naked, as we say, without the covers. There was a laser pen here, I think. Yeah. So the turbine itself is a downwind turbine. So the wind is coming in this direction, and it looks very simple. We used to have a gearbox, induction generator, sensors, a passive yaw as well. What we've now done is we've stripped everything back in the development in the years that we've been manufacturing and installing the turbines. The clever part is the rotor here in the blades. You can imagine if I'm a turbine, when the wind increases, our blades cone. So a swept area, the area that we can take energy out of the wind is reduced. So you can actually switch the load off in our turbine in a hurricane, over 100 miles an hour, and it won't run away. It self-regulates. With that as well, we have springs which compress, and the pitch angle, there's hinge blade here, and that changes the pitch angle of the blade. So it's a unique patented system that we have there. Just relaying what I'd said there. Now, for our sins, because we can do this, we never ever shut the turbine down. So a power curve never closes off. You'll see a lot of other manufacturers in the big wind as well. They'll shut off about 25 metres a second. We continue to operate right through. Some example customers that we have. Ones to note are the offshore turbines that we do as well for Shell. We're the only company that manufacture an explosion-proof turbine. Now, that doesn't mean that you can try and bomb it or anything and throw grenades at it. What it means is in an unmanned gas rig, we supply the power for the wellhead there and the communications, and it means that no part of the turbine would spark. If there's a gas release, the generator won't go above 85 degrees, which was very difficult to get to, and also the manual brake. The brake pads itself don't cause any arcing or sparks there. So that was a huge development. Now with that, what we did was, I've seen the cost of fuel there for the diesel sets, and you're saying $6 a gallon. With these unmanned rigs, the cost of fuel for this, because it's a barge that comes along every 2 years to fill for the diesel set there, the cost was over £250 per gallon for the diesel. Just flicking the switch on the diesel was over £85,000 for the man to go out there for the rig. No helicopter access, so you have what they call the widowmaker. The guys had to climb onto the rig and hook on. So the payback time for putting these turbines in was less than 3 hours. So Shell spent a bit of money with Proven, and we did development work, and they said things like, right, say something happens in the rig and you have to run with one blade, we can't get out there, we can't afford to go. So we modelled the hub, we did an analysis, and from that, instead of taking that and saying, here's a specialised, we're going to charge you 10 times the price to Shell, which we do anyway, but we took that and put it into a production model. So reliability again. What the idea is that you can put the turbine anywhere, and when you've seen there, it's 80% steel. If something happens in Africa, local guys can go out, metal bash, get it back running. That's the main thing. Minimum downtime. We also, US military in Iraq as well, and we've just been asked to do a contract in Afghanistan as well. So that leads me on to, that's where Proven are at. Now the industry, what has happened is, in the UK, there is the MCS process, and it's a certification body for that. You have it for installers, and we've had it for installers for a number of years under clear skies, which means reputable installer. If you got your grant, you needed to use these guys that were audited, you had reliability, there was a safety net there for the consumer. What then happened was there was the advent of feed-in tariffs, and you could only get feed-in tariffs if your turbine was under certification or under the process of being certified. So it's not a legal requirement in the UK, but it's required so that you can get the feed-in tariffs. Now, it's called a feed-in tariff, but actually what it is it's a total generation. So even for your wind diesel systems, we have people that have got small islands and small isolated communities. They can run their diesel, they put a turbine in, and you put a meter at the end of the inverter. That generation, they'll get equivalent, quick maths, 42 cents for the power that they produce, and they're not connected to the grid. So it means, again, payback. It's been a huge incentive. It's stimulated the market greatly. What it has done, though, it's made what was an industry which wasn't being governed the same as the large wind, like what Greg said about the North Wind there, about the design being verified, noise data. Small wind didn't have to do that, it does now. So you've got to have a normalised tower height, altitude, and the peak or rated power is a poor discriminator. So it's a verified power curve, and it's the yield now that counts. So in the UK, we're tied to the BWA standards, the IEC 61400, which is now reciprocal with the AWEA standards as well. The testing itself has to be done by a certified body, a third party, an independent body has to do that testing, and that's sent off to GEMSERV, the governing body, to do the certification and accredit that. Your factory is inspected as well, and you have to do the noise, performance, safety function, and your design file review. So your engineers that have designed the turbine, you have to give that in, and then a third party set of engineers look at the design of the turbine and verify what your findings were and why you've built the turbine to that and the safety factors. Also requires 6 months trouble-free running and 2,500 hours of power production. Now that doesn't sound that much, but believe you me, in this system that we're running just now, there's only now 4 turbines that have got through that. A lot of turbines do not operate without an issue for 6 months. So power and yield, if we think of power and we use the analogy of water in the bucket here. So you've got a hose filling a bucket, the rate of the water going into that bucket is the power, and the volume in the bucket is the yield. Now, what people have realised with the feed-in tariffs, because you're actually seeing how much you're producing through the year, is that power doesn't really matter. Your peak power doesn't matter, it's the yield, it's what your production is. Now the problem that you have in the States is that your incentives are based on, talking to Jay, was that it's your peak power, it's the label on the generator saying it's a 10 kilowatt. Now what's happened is, through time, people have put these turbines up, they're not, okay, a peak power is that at a certain wind speed, which might be 20 metres a second. What happens is, the incentives, they're looking at what the return's been and they're saying small wind doesn't work. We've found the opposite in the UK now because we're doing to the yield. So your probability of wind, you start off with your probability of wind, and you can see there, you've got the yellows of 4 metres a second, with 6 metres a second, and you see probability going up here. So in a 4 metres a second, quite often 4, 5 metres, 6 metres a second happens regular. And as you go up to the 10 metres a second, you don't get very much at the high winds, but it's still there. And in the 4 metres, there's nothing. This is the actual data that we did for our 15 kilowatt machine, the P35-2. You can see the blue are the minute averages for the wind speed and the power. The red and the green are 1 second spot points, minimums and maximums. So you can see there, you could actually draw your power curve to there, but you're not allowed to anymore. And a lot of companies were doing that. Now what we have to do is publish what the 1 minute averages are. That ends up with a power curve, which we called a 15 kilowatt previously, and you can see that at no time do we peak above 15 kilowatts. So from the standard, what we have is we have to give rated power at 11 metres a second for your 1 metre. So in the 35.2, it's a 12.1 turbine, and the peak power is again a 1 minute average, it's 13.7, but our instantaneous peak power was 17. So the games that people are playing, you've got to be aware if they're not MCS certified, because what they could do is put their peak instantaneous power and pedal the rated power there. Also, what I'd say, I'll go on to the next slide here. We can see there that at 5 metres a second average wind, now what we publish is you've got 23,200 kilowatt hours in the year. So the customer, the consumer, knows that they're going to get that. That depends obviously that the wind turbine is sited correctly, that it's there's no turbulence, it's good clean air, but that's what we can guarantee now. So the consumer has a comfort zone there. See 8 metres a second, I think Peter mentioned it earlier about the wind being a cube law. So 8 metres a second, we can save 55,000 kilowatt hours. So if you've got your wind diesel system there and you've got an 8 metres a second at 44, it's 20,000 a year that you're getting back there. Just like to show this is a genuine power curve. The red is a turbine that is a 20 kilowatt turbine. You can see there if we actually go to 11 metres a second, it's actually doing about 6. So they would have to declare that once they get through certification. And we can see there at 5 metres a second, the output there is exactly the same, because the covering area under the graph there is the same for both types of turbine. So what all that leads to is that power is a poor discriminator of turbine performance. That peak power and instantaneous power are meaningless comparing it to yield. So it's how much you get over the year. And because we're all golfers in Scotland and we always use the drive for show, putt for dough scenario, we come up with power is vanity, yield is sanity. From that. So just a quick update of where we actually are of today. There's 3 certified machines with another 3 just about to go through. And what I say there in the TL is that the transition list, so there's 90 turbines, so we've got a 6 months period of a transition where they can still claim FITs, but then they must be certified. One machine was removed from the transition list because of safety reasons. It was a Chinese import and had a catastrophic failure. As all government things, it's a bit of a mess just now, and it's difficult to enforce. The future developments. What actually happened was on the 31st of December, everybody thought they would get an extension, but the government said no. So anybody that wasn't actually certifying their turbine at that point, they've lost it. So the transition list finishes in June, and then only those that are certified will be able to get FITs. So it's driven through. Don't get me wrong, the certification costs a few £100,000 to get through, so it's no mean thing. Version 3 is coming out, and they revised the noise and to include towers. There's the one that's catching out some of the American turbines and the Canadian turbines. What was happening was we had turbines coming into the UK, collecting the FITs, and they were claiming they were a 50 kilowatt machine to get the FITs, but their swept area was greater than the 200 square metres, so they had a large rotor, so they were down rating their generators. Now what will happen is they will need to be certified as well. And digression is happening in the FITs in 2012 and 2013. So there's a bit of a Klondike on just now for people to get the FITs in. And financial bodies have looked at this, and the return on investment for one of our turbines is 18% year on year. So pension funds are looking at it as well. So it completely changed our market. But back in the good old days, just to finish off some of the historical sites that Proven have done, this was our first real production turbine, and we installed it in the middle of nowhere in the Highlands, Rannochmoor. This house here, this was a later picture. This house used to have a little diesel generator, and through kindness supplied the train station, but then British Rail and the customer fell out, and they pulled the plug. So all the hill walkers and climbers would come down and get lost in the dark because there was no lights at the train station. So we were asked to put in a turbine, and we power the lights and some of the signalling there. Lights come on half an hour before the train and half an hour after. And there's a youth hostel down here as well that's got a Proven 7. And in the olden days, what happened here was your steam train came up, they got off horse and cart down to Loch Ossian, they got a paddle steamer up the loch into the stately home. And now it's the chap that owns Tetra Pak who are milk cartons. I think he's the third richest guy in the world now. This is the Belgian Antarctic science station in the Antarctic. A great project for us. Thinking back, we were absolutely mental to take it on, as they say. This ridge here regularly sees over 200 miles an hour winds, and in the first season we got absolutely hammered. It's not like the American and New Zealand station where Powercorp were talking about, where they shut turbines down. We said no, keep the turbines running. During the winter months there, complete darkness, they don't man the station. So the guys come off, and then the first that we see is just about the end of October. The French spy satellite sells the Belgians a picture of the station in its first pass when the light comes up. So we got the first picture, and it was like, there's not many shadows, there's guys of the turbines, where are they? So if you've ever seen Apollo 13 with Tom Hanks and things, we've got a problem, how do we solve it? The guys are going down there, what have they got there? So they landed, they sent us up some pictures, and we had a month's window to come up with a design. How do we can't ship new product down there, how do we repair the product that's there, how do we get it back up and running? Funny, the field guys, it fills in with dread, but see when you've got a PD department, they love these kind of things, you know, oh, we'll work all hours, oh, this is fun. So they came up, we came up with a new rotor that could be repaired, and a jigsaw puzzle that went together and they could weld, and we knew what systems they had. And we got it back up and running, came round about, we've had another year's going, November came back, we got the first picture through, all the turbines were there, everything was running. So it was a huge sigh of relief. And we now have implemented the work that we did there into our Arctic versions of the turbine. So there's good came out of it. Picture of a turbine in the Falklands. You can't go to the Falklands Islands without seeing a Proven turbine. We've got 92 systems, battery diesel systems running there with the turbines. Fantastic wind resource. We have 4 customers that have only started in the last 5 years, started their diesel sets for exercise. It's been a huge success. The Falklands Development Council came up with a 40% grant. A number of turbines went down. We survived through the winter. We got the rubber stamp, so it's our turbines. I think it's Rolls batteries, and used to be the trace inverter, now the Outback that they use there. Fantastic for the remoteness, for the saving of the diesel, but also what we have there is, because the wind regime is we heat their water and also do space heating, because they were cutting quite a lot of peat, but since we had the little fallout with our friends in Argentina, it's a sand base, so there's still live ammo. So people were like genuinely cutting their teeth, and next thing there was an explosion in the living room and things flying about, so they stopped that. Just my last slide there. This is the Isle of Egg in the west coast of Scotland. We installed a sunny island system there. There's a hydro and 4 P11 turbines and a diesel set. It was a great achievement because the community put their minds together and said, we want to do this. They got very little funding. They raised the money themselves. They run the system themselves. The beauty of the Sunny Island system is since they've developed, they've put a little bit of solar in as well, and with the hydro, and they're looking at extending some more turbines because now that they have greater efficiency in their power, they're using that, they're doing some jumpers, what have you, the wool mills. So the cottage industry coming through, some payback for the power that they put in and for the cost. And that's me, guys, because I'm dying to see Hobo Jim, and I hope he's a real hobo. Any questions?
You haven't mentioned how they're connected to battery charging. You do direct battery charging and you have grid tie inverters?
Yeah, we do. There's three models. We do direct battery charging, which we don't do as much now because of the Sunny Island system. So you have a high voltage whereby you can do a grid tie system, but you have any excess of the turbine recharges the batteries, quite a good control system, so you can have longer transmission lines. The problem that we have with the direct battery charging is it's a low voltage machine and it has to be quite close to the battery bank and inverters. And we also do a direct heating system as well, with no inverter, just pure heating into resistive load.
Any other questions for Richard? No, way in the back.
What's the largest system you've installed?
The largest is probably the over yonder key in the Bahamas, where we had 8 of the P35-2s, which equated to about 90 kilowatts of turbine. Okay, guys, well, thank you very much.